Dear colleagues, our paper is called Methods of Eliminating Features from Linguistic Equations. The authors are Dmitry Sitnikov, Polina Sitnikova, Andrii Kovalenko from the Kharkov National University of Radio Electronics. For solving a variety of linguistic problems, some of which are described in our paper, a solution is suggested based on finite predicate algebra equations. We'll show that for some quite general types of linguistic equations, when peculiarities of their structure are taken into consideration, it is possible to develop much simpler methods for their solution. Such methods differ from, for example, heuristic algorithms that suppose finding all sets of values for semantic features, which slows down the solution finding process if the number of variables increases and time increases exponentially. We're going to discuss the tightness of links between features. It can be compared with degrees of freedom for these features. When knowledge bases with linguistic variables and corresponding inferences are considered, questions concerning determining the tightness of links between object features arise. Also, it is often important to know if such links are salient. Probably a formal link between features is stronger if fewer sets of variable values satisfy the equation. At that, if any sets of variable values satisfy the original equation, one can conclude that there is no relation between these variables. Besides, when practical problems are solved, the following questions arise. First, how do concrete values of a given feature substituted in the logic equation affect links between other features? And the second one, how strong is the logic dependence between two or more given features? We've considered different types of substitution operations. Let predicate P depend on values, on variables, X, Y, and so on, and Z. Let us define the substitution operator A of P. A is an element from the domain for the variable X that is applied to the predicate P in the following way. Let us call this operator a limiting one if the following condition holds for any X, Y, and so on, and Z. Let us call this operator a spreading one if the following condition holds for any X, Y, and so on, and Z. And finally, let us call this operator a shifting one if both conditions do not hold. Limiting operators strengthen the logic link between discrete features. Spreading substitution operators weaken such a link. Shifting operations transform the link between the features in an arbitrary way. General method for variable elimination have been considered in this paper. Consider the finite predicate algebra equation, where each variable x1, x2, and xn has the domain A subscript I. At that, for the system of features, the laws of truthfulness should hold. Also, the laws of falseness should hold as well. We call such elementary predicates recognition predicates. Suppose also that for the given values of the variables x1, x2, and so on, xq, it is necessary to compute the values of variables x, g plus 1, and so on, and xn, such that the equation will be true for some values of the variables x, q plus 1, and so on, xg. Now let us consider a mathematical representation of the elimination problem. Let us define this problem mathematically. It is shown on this slide. Nevertheless, the algorithm of variable elimination with the help of the existence quantifier has a high complexity if arbitrary predicates are considered. But we don't consider arbitrary predicates, but only those that are encountered in our tasks. Complication of the general formula for the original predicate. We are showing that, in principle, if we do not distinguish between different types of predicates, the size of the formula grows exponentially. This is why we have developed some methods allowing us to avoid this problem. The possibility of minimizing the predicate. Consider a predicate case of the defined task, where the set A consists of one element, where the below condition is satisfied. Then, as a result of the application of the existence quantifier to the variable xl, we obtain the disjunction of predicate conjunctions, the variables of which do not intersect. Then we proceed with the methods for feature elimination from predicates represented in the disjunctive normal forms. Suppose we have a model represented in the form of systems of logic equations that are written in the disjunctive normal form, where all conjunctions of different elements on the left side are equal to 0. Then, by transforming the system to a single equation, we obtain an equation in the disjunctive normal form. Then we consider a method for feature elimination from predicates represented in the conjunctive normal forms. Let us denote elementary disjunctions in the form of unary predicates and the application of the existence quantifier to the disjunction of the conjunctive normal forms means the application of the quantifier to the variable in every conjunctive normal form for which the following formula is true. The generalized method for solving systems of linguistic equations looks as follows. Let us represent a generalized method for solving systems of linguistic equations with target variables and initial conditions. Check if the conjunctions of any two predicates on the right sides of equations are zeros. Represent the original system in the form of a single equation. Substitute the initial values of selected variables in the obtained equation. Eliminate all variables except for the target ones by the application of the existence quantifier. The ordered sets of values for the target variables that satisfy the equation obtained at the previous stage is the solution for this problem. Further, we consider a method for feature elimination from splittable predicates. We have described the procedure of eliminating variables from splittable predicates in detail below. The method of eliminating variables from splittable predicates can be split into the following steps, and then we enumerate these steps. We have considered some linguistic examples that are related to Russian language dependencies. Uh, Thank you for your consideration. If you have any questions, we'll be happy to answer them.